Hello, everyone. Good afternoon. Welcome to this talk today. So I'm Kishore Kasi, and my colleagues Vikram and Tejas are here today to talk about Netflix Drive, or in short, we call NDrive. So it's a cloud drive for end users. So let's see what is some of the things we are going to present today. So we are going to talk about the introduction and motivation on why we imagined a product like Netflix Drive or NDrive. And we see what are some of the table stakes for creating a cloud file system or a cloud storage drive. We'll look at a high level what's the architecture of Netflix Drive and some of the use cases that use Netflix Drive or have been trying Netflix Drive in the Netflix Studio ecosystem. And we see some performance measurement numbers comparing it to other cloud file systems or the local file systems, and some of the features along with it. So Netflix Drive is an end user software, but connecting to cloud for all its metadata and data needs. So think of this like where users can install this on their individual workstations or their laptops or any of the endpoint nodes. So it's that piece of software which will enable users to access their data. So although Netflix Drive is a very general purpose cloud storage interface, in this context, we are talking very much in specific to how we use Netflix Drive for Netflix Studios in that context. So Netflix Drive is a multi-interface software. It provides more than one interface to manage and access data. It also is available in multiple operating systems like Windows, Linux, and Mac OS. It's available in all three flavors. It's a Fuse-based file system. Fuse stands for File System in User Space. So this is a user space software. I think as I said about multiple interface, one of the interfaces it provides is the REST interfaces. Typically for a cloud file system, it's a POSIX interface or the file interface is the common one you would come across. And REST APIs or the REST interface is something unique in Netflix Drive. And Netflix Drive is also capable of supporting different backends. When we talk about a software which enables users to access files, typically there is a backend data store which stores these files. And in a cloud drive, it's going to be some kind of a cloud backend service. Generally, it's about one backend storage, but in Netflix Drive, it is abstracted so that it can support different backend storage services. So let's see some of the motivations what enabled us or motivated us to think of providing such a new software when many such softwares already exist in the market out there. So in Netflix, as you all know, there are hundreds of new content every year on the Netflix platform. So all of this data is actually stored in AWS, mainly like S3 objects. All the media data and metadata we're talking about, all the frames, all the shots, all the versions of those shots are all stored in AWS S3. It is easier to manage, and this data accounts for multiple terabytes and petabytes of data. When managing that huge data set, I think we feel that AWS S3 provides a good storage backend. And we have a disparate metadata and data services. When we talk about metadata, it's all about who created this, and then what's the permission, which user has access to this, who has write access, read access. All such metadata information is stored in a separate service, which is kind of a homegrown for Netflix. But studio applications expect, most of them, like creative softwares expect POSIX file systems. So let me take an example. I mean, what is your latest Netflix favorite show? For me, it's a Squid Game. That's a recent one I saw. So for a show like that, in producing such a show, there are many different stages in production and post-production. It could be visual effects, it could be coloring, lighting, editorial, QC, that's quality check. So many such different stages exist. So typical to any studio, there are pipelines which take the media assets, which are kind of captured on the camera, and move them to different stages of the production process. And when data is moving in different stages, new assets are being formed, or new versions of the assets are being formed. And the applications that interact with these versions of assets or files typically expect this POSIX interface or the file interface and artists expect those to be available on their machines to work on those assets. And yeah, this is what I'm talking about, the pipelines where it carries assets to multiple stages. And the current day we live in, where right now we're going through this pandemic. When pandemic hit, Netflix, most of these artists who were working in studios in the locations, which is distributed in different locations in the world, they were all working in with the assumption of data available to them, easily accessible, and providing the user experience that is needed in order to produce these shows. They all went home, are working from different parts of the world. Now we had a challenge of how we provide the same user experience for these artists from wherever they are working in different part of the world. So that's a challenge that we were addressing at that point, and figuring out how to take the data closer to users to provide the experience they need. So thinking of that, as well as there are multiple projects for artists, not just one, there are multiple productions going on. How do we create a least privileged access for users for these data assets? Squid Game is one, Stranger Things is another one, and then maybe a different show. All different artists actually work on them, so making sure these artists have the right permissions to access those files in wherever they are located. So all these kind of motivations got us thinking of what can we develop so that we can get this going, or we can continue whatever we are doing previously. So yeah, I mean, that was kind of a origin of Netflix Drive and how it can solve some of these challenges we just spoke. So here, I just want to bring out how Netflix Drive is different and how typical cloud file systems are. So these are some of the table stake cloud file system features: namespace management, kind of creating a file, deleting a file, modifying, renaming, so all those of namespaces. Having a cloud data store and metadata store, it may be the same or it could be different, but both functionalities are needed because the data is not always local to the cloud drive software is installed. It is typically in one of the clouds, or private or public clouds, either of them. And if the files are managed as objects, that's also one of the common ways of doing it. So mapping files to objects is another feature. Maybe the files are being split into multiple objects because of efficiencies, and that's natural as well. So that's one way all cloud softwares deal with. Storing attributes that's related to metadata, and streaming the bytes as and when the users access it through the cloud drive clients. Encryption is important when this is a multi-tenant cloud, as well as access control and authentication. So these are some of the things we all know about this, and this is the table stakes feature set. So how Netflix Drive is in comparison with any general purpose cloud file system. APIs, specifically about REST APIs. REST APIs are something what we have seen as unique to Netflix Drive, and typically how REST interfaces are used is to manage the namespace, or even modify the namespace dynamically when the software is running. I'll touch on this a little later in these slides as well. So a live file system, the cloud drives have to provide the POSIX interfaces or the file interfaces where all the file operations are going through, take off anything, right? Like any file system, VFS operations have to be supported. And that's what Netflix Drive does as well as other file systems out there. A use case driven caching TS, this is interesting. If I want to compare this with some of the commonly used systems out there or software out there, typically users don't have control of when the data has to be pushed to the cloud or synced to the cloud. But in our case, since it's very workflow-driven use of Netflix Drive, the applications that are interacting with Netflix Drive have the ability to say when it has to be kept in cache, in the local cache, and when it has to be pushed to the cloud or synced to the cloud. It's very workflow-driven. So this is something that we have seen as very beneficial in terms of automated workflows, or even some of the agents which interact with Netflix Drive locally on the artist machines. Streaming support is common. That's just streaming bytes from the cloud to clients. Disparate data stores and metadata stores. I think I talked about it a little earlier. We could have very different types of data and metadata stores for a single Netflix Drive software installation. One such example could be the data could be on a S3, metadata could be on a CockroachDB or a RocksDB metadata, and or even a data store could be a traditional file system stored as files, but still accessed through Netflix Drive to take advantage of all the benefit it provides. Access control and authentication, yes, it's quite important, we all know, and then, yeah, that's one of the things that's also part of Netflix Drive. So I want to talk about some of the high-level design choices that were part of initial Netflix Drive development. As you see, it provides 4 different aspects of it. 2 of them are interfaces. That's a POSIX interface, common for a file system, and then API interface is the REST interface. A data transfer, we treated this as something a first-class citizen of when we are building Netflix Drive, because we think about moving the bytes between cloud and a local file system client is quite important to get the performance and the latencies that the workflows need. So that's also one dimension of Netflix Drive. And events. Events is about, we have a lot of services running in the cloud to kind of understand what's going on in individual clients. There are multiple artists working in different parts of the world, and whatever file system changes that they are making could trigger the next stages of the pipelines. So we want to be, the control plane in the cloud want to understand what the user is doing. So all these events are transparently provided to cloud services that we have running in AWS. And let's look at some of those, what they are, when I touch on each of these things. So POSIX interface used by applications directly. Take example of creative software like, say, Photoshop. Photoshop wants to access a file that's already there in a file system. It reads, opens, closes a file, writes something to it. All such operations that applications do, or users could be natively accessing the files. That's one way, or even the scripts or automations that can work on these files. API interfaces, and these are typically used by the workflow tools, as I talked about the pipeline different stages. If you think of an automation that typically exists in a studio environment where after one stage of a pipeline, the byproduct or the deliverable of that stage would be used as an input to the next stage. So it is kind of an automated fashion, carrying one version of the file to the next version of it. And they kind of create an environment for artists to work on the assets. So typically artists are, or generally artists have to focus on creative work. They should not be, or they need not be spending time on data management, or how do I figure out where my file is, or how do I figure out where to save, what do I name these files, and how do I manage these versions, which is the final version, which is the one that's currently being iterated. A lot of these data management task that typically an artist does, we wanted to take that away from the artist and then make it more automated or more artist-friendly, let's say that. So the workflow tools can make it possible. They can create an environment or a namespace. Say, for example, an artist is working on a Photoshop. They want to know only the PSD file they want to be using it. So prepare a namespace with that one PSD file and in the appropriate presentation of a file and folder structure, and trigger the application so that users just need to be looking at the applications and nothing else. Once they're done, they save the file is automatically carried to the next stage, versioned, labeled, all those things that happen. And the workflow tools that make it happen can use the REST APIs locally on the machine to create a namespace. That's the main use of this interface. Events, I think I already spoke about a bit, what kind of events we consume in the cloud, kind of audit logs, file creations, saves, deletes, such kind of audit information, metrics. This is about performance to understand what's happening on the client. Those are also published to the cloud, and updates. I think the last one is an interesting one. I can touch on that a little later as well. This is about a cloud control plane remotely defining the namespace or modifying the namespace of a user who is on the edge. This is kind of a center in the edge model where in the centralized control plane, and the users on the edge in different parts of the world look at these namespaces, but that is always controlled by the services running in the center. So this sort of use case do exist, and it's quite useful in some of the workflows, and that's available in the NDrive model. And the data transfer, as I mentioned, there are two kinds of storage we use. We use local storage for caching the data, which can provide the performance benefits of a local file system. And we also have a cloud storage, which is the backend data store. And when you think of cloud storage, it could be, again, you could think of multiple layers of cache there, which we call it media cache because it's used for storing media. And the centralized long-term source of truth information stored in AWS S3. So this is how it all comes together. We have the control plane operations, that's one dimension, the data and metadata operations, state changes, updates that we want to propagate to the cloud services, along with the data transfer which interact with the data storage. So now going back to how all this fits together, what are the building blocks of Netflix Drive? At a high level, you have the interfaces, two kinds of them, the storage backend and the transport service to move the bytes to the cloud. I want to focus on the storage backend here. We spoke about abstractions that Netflix Drive has in its core design principle. If you look at, there are three abstractions that we have created. One is the abstract metadata interface. Here, the metadata interface or the service that provides the metadata could be different for different applications or for different users. One of the common examples is metadata stored in CockroachDB or CRDB. It could be a RocksDB, MongoDB, anything for that example. And in Netflix, we use CRDB to store our metadata in one of the workflows. And similarly, for data interface, it could be AWS S3, or it could be EFS, could be another file system, or it could be a local file system altogether, because entirely Netflix Drive could be run on a local file system. That's on a data interface. And the security. So security angle is quite important for us, or it was important for us from day one. If you take a file system in the data path, the security is kind of a old school model of ACLs, access control list. If you take NFS or SMB, it could be an Active Directory or a Kerberos, an LDAP-based model. So some of the new security mechanisms like two-factor authentication that Netflix uses were not possible in the traditional file system context. So we were thinking, how do we bring the existing security model of Netflix into the file access as well? So, and that's one of our thinkings, and then we understood that every single user or every single the future user of Netflix Drive may have a different security model. So we also abstracted that. So although we don't use Kerberos today in Netflix Drive to do the ACLs or the authentication and authorization, but that's one possibility. What we have done in Netflix is to have a common metadata and security services combined. So, but we do have abstractions available so that they can be separate if needed. So let me touch on some of the use cases. So here, first I wanted to give a context of what happens in a media workflow and where Netflix Drive fits into this big picture. So this is at a very high level view of how Netflix services interact with each other in a pipeline, or how it interacts with some of the vendors Netflix uses for its production and post-production activities. At the top, if you see the media exchange workflows, so this could be individual stages in the pipeline, how it exchanges information from one stage to the other. And then the other one is the partner API integrations, where some of the vendors use Netflix, do work for Netflix productions or post-productions. How do they upload the data to Netflix, or how do they consume the data from Netflix? They could have their own API integrations. Those are possible here. So they interact with appropriately the layers like either a UI interface or could be a programmatic interface through partner API that Netflix provides. All these things are driven by the media workflow platform, or we call it pipelines. And pipelines uses the underlying services, like for example, the media the inspection and the encoding services. This is a platform services within Netflix Studio infrastructure teams. And then, or the asset management services, in order to understand what is an asset made of, how many files it's made of, what its presentation. All these are individual services which are leveraged by pipelines in order to achieve this post-production activities. And again, now all these services have the need to access the data, either to write the data or read the data from it, or modify the metadata or attributes of it. And these services leverage Netflix Drive to accomplish those tasks. And you also see these two boxes on either end, which is about all these services are built on top of common Netflix platform tools, or we call the paved path services. Any service that we build, there is a support, inherent support through Netflix platform about like how do we deploy this, how do we monitor these services, what is the performance, what are the metrics, how do we view them. All of these come from the platform tools, the common platform tools, and that's what they indicate. So I want to capture some of the use cases which either use Netflix Drive or either we have evaluating Netflix Drive to be used in that context. For example, like artist workspaces. Let me go back to this. Artist workspaces are like, how do we create a namespace for artists to access their files? I've already given one example of one of the shows, so that's one of the examples. And then users have their own preferences, like softwares. If you're working with a creative software, then what's the preferences the users are comfortable with, what kind of brushes, what different styles, and those sort of things that users want to store, and they want them to be, want those user preferences to be available any machine they start working with. For example, they may use their endpoints when they come to Netflix offices, but when they go back home, they want to use laptops. So such kind of, but they still expect the same preferences to be on either of these places. So that's one of the use cases. And a workflow-aware asset store, this is like workflows defining what assets, what versions to bring, and what versions to sync. So automated workflows. And the container cloud storage. This is also used extensively in the automation. So this is one view of like how the shared workspaces have been accomplished. NFS is a wide common protocol used for shared storage. So Netflix Drive is not NFS, but it wants to provide the constructs of a shared workspaces whenever the users want to share between multiple users, or imagine a team of artists collaborating on a project where they want to share their updates with each other. So it's one such use case where imagine at the bottom 2 boxes you see there are like workstations. To the left is like a workstation A, and to the right is workstation B, which is like 2 artists are using them, and they want to share files between them. So how could we accomplish? Imagine their workstation could be, one of could be Mac OS, other could be Windows, but they have their Netflix Drive software installed, appropriately pointing to a project where assets or files are available for that working group. Whenever let me go take particular example of a user in a workstation A creates a new file. So this file now is locally cached in the local disk. And then we have a caching tier which can help in destaging these files. So this file could be available in caching tier whenever the Netflix Drive workflow defines it, when it needs to be taken to the next tier. And all the users within the same location will be connected to the same caching tier, so this is available for them almost immediately. And then if you want to share it with like a remote user in a different location, what we leverage is something called a shared file session. This is a concept of file session which spans multiple users and multiple locations. So this shared file session is constantly being updated based on the user metadata operations, and whenever the file needs to be shared to a different user, so the shared file session takes on the responsibility of whatever the mutation is had to be replicated to the Netflix Drive in a different location, say in workstation B. So the Netflix Drive in workstation B gets these control messages of this particular file has been modified, and that Netflix Drive will appropriately download this data either from a centralized cloud metadata and data store. In this example, the cache would be pre-warmed, and then whenever the users access that data locally, the data could be retrieved from the cache tier, which is the green box, and could be going to the local storage. So from there on, the users have a local file system experience for that matter. And all of this happen transparently without users getting involved of, okay, when to sync it or when to update their files. So this is one way how Netflix Drive can be used to provide like a shared workspaces. An asset store. This is very kind of highly controlled by the local agents that are running within the artist workstation. So I want to like go through this workflow of, say for example, there is a DCC software, could be Photoshop, could be Nuke or Maya or any such application. Users interact with the software, and the software reads and writes data from the Netflix Drive. In this example, we have a path of mount and drive and media assets. That's the location of all the files exist, and users interact with it. And there is a asset web UI and plugins. So this is all about monitoring or even understanding how users are interacting with data. Say for example, when users save a file. So these plugins get these actions. Based on the action, it would trigger an appropriate REST interface in the Netflix Drive. In this case, save. When users save the file, the plugins will in turn trigger Netflix Drive to sync the data to the cloud, and Netflix Drive will talk to the data orchestration service which is running in the cloud. All the right-hand control plane cloud services are running in AWS. So they interact with data orchestration service, and then the media pipelines would be triggered as well to say that one stage is complete, which means that that file session now knows there is a new mutation of a file. So the file needs to be shared or to be taken to the next stage of the pipeline. The file sessions would trigger the next stages of the pipelines as kind of defined, right? For example, it can go from one user machine to another user machine, or could be going from one user to an automation like an encoding or rendering or any such things. So the container cloud storage, this is one other way of showcasing how the automated workflows can also leverage Netflix Drive. Think of where there are backend services or backend post-production workflows which want to spin up multiple containers in order to work on the data. Could be a quality control, could be figuring out how the frames are, or if there is anything that's wrong with any of the pixels that has been captured from the photography. So all such workflows can spin up Netflix Drive, and these workflows already know what are the frames exactly needed for one particular container and can only bring that frame. So it's very tailor-made namespace for that workflow. And even this is one of the use cases that we use Netflix Drive today. So let's look at some of the NDrive features, and Vikram is going to talk about them.
Hello, everybody. Thanks, Kishore. So we spoke about a lot of features so far, and what I'm going to cover now is what is kind of different and what is distinct, and kind of tied back to some of the motivations we spoke about, Kishore spoke about earlier. So one of the key requirements for us was providing a secure access to all of the universe or corpus of data and metadata we have. So there are multiple backend services that manage and store and provide access to data and metadata, as Kishore has already mentioned. So we built in a two-factor security model. So one is authentication, and this basically allows or opens a gateway for Netflix Drive running on users' endpoints like laptops or cloud provisioned instances to access the backend services. So these are, could be in the form of certificates that are situated on the endpoints that kind of opens the gateway and uses a secure model. And then the next level is a finer-grained access control, so authorization to specific assets and, that are manifested as files on the users' laptops and workstations. So that's kind of the second level of security that's there. So let's see how that kind of is implemented. So when the laptop or the endpoints are provisioned, either the users or the agents, automated workflow agents that are deploying Netflix Drive on the endpoint will situate authentication tokens, which is consumed by Netflix Drive. And then they're used to access the backend services. So these tokens are flowing back and forth, and this opens up access to the, there's a mention of CockroachDB deployment or DynamoDB, whatever the metadata service could be. And similarly, the data storage buckets. So once that is established, the next level is the authorization. So that for the individual files and objects that are manifested as files need to be projected onto the user's endpoint, and that shows up as your standard POSIX permissions. So that kind of the translation is managed by all of these things. So it's kind of a slightly different model where the metadata could be stored. I'm talking about the file metadata. So from on various backends, and so kind of we pull those, translate them, and then use it for enforcing access control. So the next distinct feature is dynamic namespaces. So typically, when you conceive or think of a file system, you start it up, and then you have a root node or a mount point, and then from there you see the hierarchy of files and folders that are either created or stored, copied from somewhere, and that's one thing. But since Netflix Drive was conceived to be used not just by users, but also in highly automated workflows, we saw a need to be able to curate this namespace and be able to dynamically project and also remove as the needs arise in the workflows. So that's the concept of dynamic namespaces. So this is achieved through APIs. So that plays a big role. So the APIs is a big part in the rich control interface and control IO interface as well. So as an example, so that we could think of an agent or workflow agent that runs on an automated workflow endpoint, where which is aware of what to project onto this instance. So that could drive the APIs to add an instance or a folder to show up, and that will pull in all the relevant files. And they could be on disparate systems. So they don't have to be in the same hierarchy on the backend storage. So we kind of put it together and then present it on the namespace. And similarly, it can be removed as the workflow demands. So another key distinction is the ability to have multiple instances. And I'll tell you what instances means in this case. So we talked about the ability to have projections of multiple or various backend systems. And this kind of gives a way to tie together the various data and metadata stores and project them in the same namespace on a workstation, if the workflow demands such a thing. So what you see is kind of a noisy slide here, but it gives you a range like the highest possible controlled configuration end. And at the lowest spectrum, this whole thing could be an empty, like a JSON specification or with minimal specifications. So for a user to use it as a user preferences or a software preferences mode, they don't have to worry about all of these, the security paths or the metadata store locations or the data store locations. They can all be inferred. But for automated workflows where there is a need for control and curation, they can specify and drill down to the lowest level of configuration. And one of the things, the last row there, instance type of dynamic end user, kind of gives the maps to different capabilities based on how the instances are projected. The other thing is that kind of distinguishes the tiered caching. And the main distinction here is a lot of cloud file systems do have caching and caching tiers. But here, what we have is a user configurable and workflow aware caching. So we don't throw it in for all the use cases. So the workflows that need it can specify the caching tiers. The ones that don't can go directly to the cloud, things like that. And this also has a level of control of how frequently we kind of sync to the cloud. So that also can be configured. OK, so a little more deeper into the APIs and how it ties to, as an example for creating namespaces. So when Netflix Drive is bootstrapped, users can spend the previous slide that had all of the JSON specifications, kind of is a static namespace configuration. So a Netflix Drive can be brought up with this configuration, say, OK, I want these specific data objects and the corresponding metadata that goes with them to be projected into a namespace on this instance of a workstation or a laptop. So that is one way of starting up and drive. Another way is starting up with a blank slate, like an empty mount point. And then through APIs, driven by the workflow agents, you could populate or hydrate the namespace. Or do both. So that's also an option. So it's kind of highly configurable and flexible, so it can be used in multiple workflows and along the pipeline. We tried to conceive it to be able to be used from the point of ingest at the edge to kind of the final product is produced. OK, so those kind of some of the high level distinctions. Now we'll delve into performance. And before I go into, so there are a bunch of charts here that shows the numbers and figures. But before we go into that, I want to talk about the model for this and the motivation for the model, and also some of the configurations we used, which are relevant for the studio use cases and some of the use cases that Kishore spoke about earlier. So we see two main types of workloads. One is sequential IOs, and that is typical of any media assets, which are large files of video frames. So applications that, like Photoshop or Nuke or Maya, that are used for editing and even VFX work, deal with large frames of video, and these run into tens of megabytes to hundreds of megabytes. So typically, these translates into sequential reads or writes. And there are other use cases for small metadata files and also user preferences and home directories, things like that, that are typical normal I/O, which is 80 read and 20 write. These workflows, so we kind of, that's one dimension of it. So other dimensions, we wanted to kind of baseline it and compare it with a local file system. So in this example, we used XFS. And then, so the other curiosity factor is, since we use Fuse, what is the overhead that Fuse brings in? So that's the other factor. And then the third factor is Netflix Drive itself. So what is the final, like the new features and we have added that kind of brings in overhead that. Pause for a minute. So going back, so what you see here is, so kind of we we used a kind of a de facto industry standard FIO tool to run these measurements. And so as expected, for random performance, we have XFS, the local file system, without any overhead layers of Fuse, kind of outperforming. But the other goal for us here was to also measure the variation and also how much Netflix Drive is different or underperforms, and kind of we wanted to bring it within the tolerance band. So the parameters of the metrics we looked out for was the IOPS, which kind of gives the throughput, because many applications are IOPS sensitive. And there are other applications that are latency sensitive, kind of time to the first byte that comes in. So there is by default, Fuse has a read ahead in the kernel. And so that kind of gives an advantage in some cases. You'll see that in the sequential numbers. So you can see that the bars are almost the same in many of the various block sizes where sequential reads are performed. So throughput, they're almost equal, like very negligible difference. So there are other knobs that we have tuned in the project. This is a continually kind of ongoing optimization. So we also have an ability to enable write-back caching, so which basically avoids double copy. It's kind of a Fuse internal notion, and we're taking advantage of that. Similarly, latencies also for large sequential IOs, again, because of the read ahead. So this table, as I mentioned briefly about the underperforming and the tolerance band, and we kind of, we've been tracking this through a color-coded system, where if it's within 25 or 15%, I think, we kind of made it green. And so if you look at an example of sequential read, for example, so XFS for large IOs, 627, and it's almost comparable, like the same thing, XFS being the local file system, and Netflix Drive, almost, it kind of pretty much all green all the way through, and in some cases, even outperforming. And this is because of the performance tuning features I mentioned, the write-back caching and the read-ahead that Fuse has. And the other thing is Fuse also allows larger block sizes, so 128 megabytes, which is different from XFS, which is by default 4 KB. So there is some advantage there as well. And then, so the reds and the oranges are kind of the things we are watching out for, and some of them, depending on the tolerance limit, we're tracking it that way and kind of trying to improve the performance. Again, similar here. This is 4K blocks, and there we kind of fall short a little bit. All right. So that kind of brings us to the end of the talk. We've kind of detailed all of these things and our thoughts in a series of blog posts, and that's the link there is the first one. And kind of go deeper into all of these aspects. And following that, we'll probably have more. We'll probably pick out certain things, maybe performance as we are doing more things, and kind of write more about it. So please do follow those. And thank you. Bye. So we have a few minutes for questions.
You can go upstairs.
Building like a proxy or transcoding the video for latency reasons, or is that at a whole different level?
Could you, do you mean for specific?
Yeah, like when you go to video assets, are the end users watching a proxy of the actual video itself, like with a mezzanine high quality video? Or are they utilizing the actual video,
Got it. Okay. Okay. So let me repeat the question. Yeah. So it's about whether it is kind of toning down the quality or transforming it in any way to make it more performant or easy to use. No, it's not the case, because in most cases it is the same high fidelity, whatever the original that is projected. And we have read ahead and things like that to make sure it kind of the time to first byte is shortened.
But there is also, depends on the stage of the workflow. If the workflow, for example, is editorial may not need the 4K frames that's been shot, right, in the principal photography. So it goes through dailies, and then you create the proxies out of it, and the editors may be looking at only proxies. And so that's why the workflow agents, which are aware of the workflow, bring or hydrate the Netflix drive with appropriate files and the versions that needed for that user. But in some cases, yes, the users may need the high resolution, the 4K frames that has been shot in, and they would continue to use this.
Any other questions? Yeah. So we use encryption, right? Encryption at the client side when we encrypt the data and then we send it over to the cloud, and that actually protects a lot of the data. And we also have versioning of different objects. So I think even if such a scenario were to happen, you can always go back to the previous version and hydrate your systems with that. So those two can protect us against ransomware.
Else at a remote location says, you know what, I'm going to edit that same file.
Yeah.
How is file locking handled where the second guy is not working on, dead man walking file?
So that's true. That's typically available in a shared storage with NFS, like file lockings are available. But in our case, we are not providing something like a global lock to the file. Every individual user is working with their own version of the file. Say, for example, a user A updates a a version X of a file. So they're generating a version Y of the file. If the version Y is needed by the another user B, then the file is like the file sessions take care of what the files have been modified. The current approach, what we are taking is quite simplistic, and we anticipate the workflows to actually handhold them better. So the last writer wins. So if both of them are updating the same file, the file session in the cloud, and whatever versions make it to the cloud to the end, that's what that wins today. For most of our workflows, it's good enough because we almost rarely have a situation where both of them are working on the same file and modifying the same content. Usually, an asset is made up of like multiple like small assets, and they do work on those small assets, and finally they all come together. So not a major need for a use case, but I can see it is applicable in other cases. Yeah.
So in some ways, we can support both the versions. Like generally, creative processes are iterative in nature. So in our case, we see artists that work on an asset, and only when they want to publish an asset, they call the relevant APIs. So as long as they are working iteratively on an asset, there is no need to hold a lock on that asset, because only the final copy will make it to the cloud. So I think in some ways we are different in that sense, where we don't hold a write lock on a file for local iterations. So multiple artists can continue to work on it without like tipping on each other's toes. So that way we are different than those traditional modes of having write or read locks on a file.
So most of the workflows or users have an explicit intent of sharing or publishing to the cloud. Without that intent being executed, the users are in their own bubble. They can change and modify whatever they need on the files without any locking. And that also helps in providing a performance that user needs.
So they check an entire project at a time, localize it, work on it, and check the whole thing back in?
Not the entire project, may not be at that granularity, maybe some more fine granularity of single asset. It works on an asset basis, but the Netflix Drive work at a file level. It's one more level deeper of an asset. An asset could be composed of multiple files.
But you're right, I think so notifications could be used for such advisory locking or lock surrendering and kind of things. And in the shared workspace use case, that we don't use it for that, but we kind of use it for cache invalidations, because our usage model doesn't really need a write lock, global write lock. Kind of.
So far, especially with different post houses, as an example, we haven't done that with different houses. So the one picture I was showing up some time ago, they do have the API integrations where data flows between vendors and Netflix ecosystem through those APIs. They are not actively using Netflix Drive at this point. Yeah.
Do you guys have an intent to one day do that, or is it still kind of you're doing it kind of as an in-house proprietary?
That's a good question. I mean, yes, naturally, as a progression that might happen in the future. But I do understand where all the different vendors and post houses have their own storage and their own way of looking at things. I think it's an evolution to figure out.
Also, one thing is that we are planning to open source Netflix Drive as well, because we think of it as a framework that can be used outside of just the studio applications itself. And because you can plug in different types of data stores and metadata stores, it can really be used to solve many more richer use cases. So in that scenario, many different types of applications can leverage the same framework and see how it fits well to their needs.
Cool. Okay, cool. Thanks, everyone.
Thank you so much. Thanks for attending.
Thank you.